Okay, starting this a little bit too late, but because that's fine. We can have like a lo-fi study night. Music is uh lo-fi girl, lo-fi boy. First question we need to answer is, what does the system design look like? So basically, what constitutes a system design? Question and answer. What is the interviewer looking for? What should one structure their answer? Finding, structuring the answer. Choose your own adventures. There's no correct answer. I think as long as you can justify it, agree? Hmm. Design YouTube. Design URL shortener. Handle ambiguity. Thinking in component. Okay. Yeah. Load balancer we talked about in the previous stream. Oh, we forgot. Study me system design. Forgot to change the stream title. Software. Study with me. Let me take a look at the stream manager and make sure everything working. Yeah, looks like everything working. Yeah. Okay. So with the writing the note here. We looking for ambiguity. uh, by design. Okay. So component design. Scale. Mm. So look for trade-off. Okay. Back at the envelope math. Okay, some um, um, napkin math. I just don't want to copy outright. Napkin math. Basically, any estimation of the resources. Reliability and availability. So this is in case of like outage. How does it operate? Okay, availability and reliability. So they expect you to lead the question. So basically, um, like active participation, or um, leading the conversation. Okay. Pro tip: you don't mention a trade-off. You haven't really designed anything. You just list the technology. Okay, so trade-off is important. So structuring your answer. You want where did they source all this thing? Someone probably wrote an article about this. Let me load the music a little bit. Okay. So in most of the stressful like um situation like an interview, right? So never jump straight to the answer. So steps you want to do. The elite. Okay. This eventual consistency is fine. So basically the first step is requirement clarification. Has functional and non-functional. Functional mean like what is it that the service or your design is solving, right? So what problem that you are solving, right? Non-functional. So this is like uh, the outcome of your design. So like add-on, right? Outcome of the design. High level design. So you should start with a happy path design. Yeah, makes sense. So basically, you need high level design. So basically, um, me put on some light so that I can write. I have some light here. This should work. Okay. So writing some note here. Okay, high level design. Do you want the happy path? So basically, happy path. I think happy path would just be fine. Data modeling. Okay, so high level design should be 10. So 5 to 10 minutes. So this is 10 to 15 minutes. So 5 to 10 minutes. Right. Data modeling and API design. So data modeling and API. 25 to 10 minutes. So this is just your interface to your design. Like, does the customer or the user want to call this API to achieve their to get a problem, to solve that problem? Okay. So this is the schema, basically how do you store the data. So you do API to schema to storage. This is pretty like self-explanatory, right? So you started with the API. No, I think you should start with the storage, right? So API will be endpoint. Schema is like basically data shape. Data shape. Database. API basically function, endpoint, and so on. The deep dive. This is where you show your expertise. Okay. Scaling. How do we handle separate people 50 million per follower posting a tweet? Can they? Yeah. Okay. So deep dive. This is 15 to 20 minutes. B. Scaling. Caching. Where should you place the cache digital? So basically, like, instead of always hitting the database, you set up the cache so that um, reduce the load. So with the expire date, partitioning. Okay. Okay. Partitioning, probably you have to figure out your load test, right? So that you see like one group of server, how many requests can you handle, and so on. Go to rule of system design. Hmm. So the golden rule is justify your answer. Yes. Okay, so let's think about this question for a moment. Design a URL shortener. So following this framework, so I say for requirement, you need to so let's actually write them in Notepad or something. Okay. Design URL shortener, right? So to structure our answer, okay, let me actually switch to display capture, I guess. We can have a notepad here. So Gemini recommend I do this. So first we need to figure out the requirement, functional requirement. So functional requirement, we have to say, I guess, given, so basically the user can like give a link to an URL, and it should shorten them. So the interface here may be a website, like with a text box or something, with a text box, or an API call, right? If we let them call, right, and it should shorten them. So like, for example, right, abc.com, https example.com become tiny dot 123 or something like that. And the non-functional requirement like is the LT latency. Um, so something we think about is for this as well is does it, let's write them in like this. Okay, so the first thing we need to gather the functionality is does the user require a login or is anonymous or anonymous interaction is fine. How do we guarantee uniqueness so as to not swarm the system, right? Or do we throttle the customer if somehow we figure out that it is the same caller? I think for this we can do IP address limit or something, right? Yeah. A non-functional requirement we want to find out is basically we want low latency, so like in high availability, right? I guess pretty much that's what it does, right? So availability, yeah. So step 2 is we want the happy path. So let's do this. Make a photo here. Let's call this system design. URL shortener to that. So step 2 we gotta do is we gotta get the happy path. Okay, so basically I need to componentalize stuff. So I imagine the front end, and then so basically this, it will serve all the interaction, and the basic level that should be a backend, right? So like we have like a website. I'll be down with the website, so that like, because most of the user would just want to go to the website and paste the URL that they want to there, right? So the website, and then obviously you want to pick some kind of database. So there should be a URL if I can, right? The state you identify the major component. Okay, happy path data to your system. So the user go to the website have a text box or something, you enter the link there, it would just give back the so I think the high level design and the API design, I'm just gonna give it to into one. So let's do step 2 plus 3. Right, so let's give API, right, would just be we do something like the endpoint will be post to v1 URL shortener, right? So you would give the URL here, right? So basically the input will have basically the URL HTTPS URL, okay. Or yeah, so what is the requirement of the HTTP URL specification? So standard, just look at some of the URL, right? So yeah, just need to read this after. So we just need to do this, right? See the output would just be, so this can be a string, right? So you're a string, right? This is the URL. This is basically the input URL. And the output also string, the output URL, right? So what kind of exception would it throw, right? So like, let's say the service is experiencing like an outage, then it would just be 404, like maintenance, or like maintenance, or like either schedule. Oh no, shouldn't be not found. It'd be 500, right? 500. So basically could be schedule, maintenance, or system down, right? Or like etc, right? Right, what are the exception that we can do? So let's say they trying to DDoS us, right? This should be 400, right? limit exceeded. HTTP code for limit exceeded. 429. So 429 basically limits too many requests. Right. Okay. Or so let's just make this become a dot. Become dot. Right. Well, what are the common CPT code for API? Oh yeah, of course. It's like on success returning 200, right? Who's beginning mostly? Okay. Success. Probably we should study this HTTP code later on. So there's some client error. Right? Forbidden. So let's say do we want like authentication or no? So something to do the note about. Do we want authentication? So let's put the question here. When authentication and authorization. So this is to me this basically for monetization, right? Because probably we gave better rate. Oh, sorry. Look at some text here. Right now, design tiny URL. Oh, URL shortener. Okay, so if we let's actually do this, it's fine. Keep bidder rate or TPS if the user pay for usage. Okay. So because I think otherwise most of the time you want to go to the website, you paste the URL there, you keep like a shorter link, right? Yeah. So yeah, that's the exception. Basically, you go to this URL, like example, like if I do do a post v1 URL shortener with like example.com. It become like ABC123, something like that, right? Like for example, let's see what they've been doing, right? Well, they have a domain and you can have alias, right? Let's say we do https example.com. Question is, does example.com exist? Yes, this is your function domain. Okay, some interesting thing to think about. Okay, so example.com exists, right? We do this, shorten, become, this is example from the existing service, so we want to do become this, right? It doesn't look like it's shortened, right? So, well, hopefully, right? So that is the API. So we can remove this. Oh, sorry. Right. So we can remove this. So next thing gonna be data schema and storage. Okay. So central to this URL shortener thing is you want to know how do we map this to a shorter name, right? With some sort of a domain, whatever, right? You can see here, right? This doesn't look like it's shorter, right? Because this is too short already, right? So we want to look at our Python and see, confirm that, right? Len of this way. Oh, sorry. And length of this way, right? So it's actually longer, right? So who said that you need to be, is the requirement? So the question we need is we need to ask, probably ask the interviewer is does it guarantee that the URL will always be shortened, or is it just needing to be like random enough, right? Like case in point, the tiny URL that we've seen does not actually shorten them, right? When we paste this, that. Okay. So this is what I come up. Okay, let's do another thing is what else can we think about? Like you given an URL, you make it shorter, or you just map them to different characters, right? Whatever it is. Right, so if we see what tiny URL does, right? Somehow map example.com to this number, right? So really really we should just compare after the domain. So in this case, it is actually shorter, right? We have example.com and somehow become this. Yeah, it's actually short enough, right? So the question is that it's okay, is kinda the question that we asked earlier, not thought through, because this is actually shorter if we look at after the domain, right? Something like that. Okay, so the main thing left is we have to somehow map this example.com to something like this, right? So really whatever left, we need to do some kind of passing scheme, right? We want to somehow make example.com become something like this, right? So I think it's gonna be some kind of hashing. So we have example.com become 55Z34528 or something like that, right? So the first thing we think about is how does Python does the hashing, right? Example.com, right? It give you something like that, right? So mainly, so we need to look to some sort of mapping a string to unique ID, right? Right, so but in this case it doesn't actually look shorter, right? So but no, it needs to be shorter, right? So how do we make it become shorter? So the first thing we need to think about is basically what is in the URL here format. Mm. Oh, so you can even do the thing here. Oh, okay. So something we should ask is, does this support international internationalized URL, right? So, meaning the URL is actually UTF-8, right? And the second question is, does it support percent encoding? Right. So basically in the Wikipedia, if you do this, it becomes this. So like this example is the Chinese URL. So we shouldn't click this. Make it render become clickable, right? Become this. Right? Okay, that's two of the major questions that we want to ask the interviewer and see if what they think it is. We'll come back to this maybe, but um, for now, let's assume, because does this change your design in any way if you want to support those other things? Let's assume it is English only, which means alphanumeric, right? Okay, that's the question that we want to ask the interviewer and see what does they expecting, right? So now come to the central part that we need to talk about is, let me grab some water. So the main question we want to ask about is, how do we make the example.com shorter, right? So Meaning, like, how do we figure out that this thing right here, 55Z 34528, what is the length? Right? What is the permissible length of our return, right? So each of these would be like 8 byte, right? So E2 X1 A1 M1 B1 L1. How do we do it? So what sort of compression string algorithm exists? So this is what I thought too. We do a run length algorithm, eh? Run length encoding. Oh, okay. Run length encoding, eh? Right. That's what I thought too. See? It's what example.com become. E2, whatever that is. So, but this thing give a problem. Let's say if you have like everything length 1, right? It make the string actually longer, right? So like, for example, if none of the character repeated, so like abc.com, right? So the first thing I thought of is RUE run length coding, right? So like example com become e2 x1 a1 m1 b1 l1 e1.com, right? So in this case we actually did not save anything. Problem is, if the input has no repeating characters, then we actually lengthen the string, the input, instead of shorten it. So no go here. So no. So I know that like if we want to shorten the string, right, we have to somehow have a way to reduce that, right? So we gotta figure out some sort of compression, right? But right now I think if I use run length encoding, it would give a problem. Because like I said here, if you don't have anything repeating, you actually make the problem worse. Okay. Maybe we can use any of these. This Huffman coding. I mean, I heard of it, but okay. So actually, let's do Huffman coding online, right? So if we do example.com here, what does it become? We compress actually. What is this? Okay, so binary to hex, I guess. If we do this, become this, right? So second thing we can do is Huffman coding. Okay. So example.com become this. This shorter? I think so. Length of 9, right? So we actually say 2, right? So I think central to these URL shortener, you just need to. I said mapping here is actually wrong. I don't want to edit it, right? So this is gonna be compression string compression algorithm or something like that, right? So they said we can use Huffman coding. It's the lossless data compression. We'll have to read this paper, I guess. Just download it. Oh my god. Okay, fine. Let's download this. Where's the download? Read this more tomorrow. They do some statistic stuff, right? Just make become a tree. So what other thing that we want to look for? There has to be some sort of mapping, right? But like the simplest thing that I thought about earlier was runtime encoding, which is like it's actually make it worse. Maybe this is okay. Who knows? It's subjective. What is this? Arithmetic coding a symmetric numeral system. This one. What does it do? Entropy encoding. Okay, that's the term that we need to know. Information theory. So maybe we should read more about entropy coding. Let's actually open up another Gemini. We study system design here. We don't want to interrupt this. Go here and say, here we have new stuff here. What is entropy coding? The lossless data compression. What is this? I don't want to know. sorry. I was just this thing pops up. So annoying. Whoa. We have message and Sophie coding. Look for patterns. Redundancy in the way symbol like letters or pixel. Assign shorter code to the most frequent symbol. And longer code to the rare one. Variable length coding. Yeah, that's what we found out. Well, it'd be interesting to implement this tomorrow maybe. So let me write a note. Huffman coding implementation. I don't know what they meant by this. The math behind the magic. Okay, Shannon entropy formula, okay. Shannon information theory, right? And information, this is the father of information theory, right? Is Shannon the father of information theory? Yes, Claude Shannon. Oh, is that where Claude come from? Claude Code? Okay. What is the origin? What is the origin? Claude Code. Claude Code name. Yep, I was correct. Let's do this. Okay. We have to write a blog post later. The entropy calculated as probability of the ith outcome. So this is saying arithmetic coding is more efficient. Yes. Give example. Don't tell me how to implement stuff, because I want to implement it as well later on. Let's do Huffman tree, right? B so like we have 6 total vector. 1 2 3 4 5 6 but only 3 unique. The goal is yes, but also give me the result with my input string sample.com. Oh. So let's look at the banana, count the frequency. So A appeared 3 times and appeared 2 times. We have a branch with a value of 3. Now remaining letter A with a value of 3. You find 4 to every left branch, 1 to every right branch. Compress the data by, oh nice. I think this arithmetic thing seems too complex for me. I'm fine with Huffman too smart for me. Do Huffman coding with input sample. Right. Right. So so 88-bit Huffman is like 35-bit. This is TPD. Yes. Okay. So another thing that we look at is arithmetic. What's it? Arithmetic and coding. Arithmetic coding. Arithmetic coding faster than Huffman, but seems complex for me. But let's look at it tomorrow. See if it makes sense. Okay, so this is actually, I need a cross off here. Maybe a better in text that I should do is probably I should do markdown, but that's fine. So this is actually compression. Right. Okay, so this is what I'm coming out of storage. So we basically just do we just store them in the database? Just store them in a database like DynamoDB. I think even the relational database should be fine. Right. Okay, because they probably support sharding, right? If our column is varchar, right? So what is the max column size varchar or Postgres or something like that, right? $10 million. Right? So what about what is the max size of column in NoSQL? Right. So Amazon DynamoDB is 100 kilobyte. Oh, this is the row size. MongoDB. So I guess we need to find out like, okay, so the input to our thing here would just be like, what is the max? The max size. Okay. So that means what is the maximum size of an URL, right? Okay. Oh, so the maximum size of the URL is 2048. Whoa, look at this. We go to a rabbit hole here. Okay. So assuming, what did they say here? So basically the TLDR is 2000 to 8000. I do not know this. This is why Stack Overflow is so good, because these people actually dig deeper to give you a rundown of what it can be. Well, does this block exist now? Ooh, there's more stuff to read about. This answer is good. So they're saying 2000 is actually something for 2083 is something for Internet Explorer. Hmm. Okay. Oh, CDN has limits. Hmm. Wow. Okay. This is a popular question. While modern browsers support longer URLs, search engines do not. So the headline figure remain under 2000. So let's do this. Example of a longest URL. Oh my god, there's a subreddit for this. No. Hmm. Let me put this into my note here. The longest URL seems to be from this Reddit, right? There's a lot of question asked. A wild story. Wow. Oh, this is the interesting thing. Very nice story. I heard of this before. Okay. Nickelback. Dude. Nickelback is pretty good, guys. Go and watch Nickelback. So there's a website for P. Whoa. Pi, sorry. This information up to date. What? Oh, we can do this. So if I do this, if I put this into tiny URL, what happens? Where's the tiny URL link? Yeah. Can I do this? No, it doesn't even let me paste, right? Look, right? So if I do half-man coding, right, whatever this guy does. Oh, impression is actually 75%. Very nice. Tomorrow we should start looking at half-man coding, right? But what is the longest URL right now? What? Okay. Yeah. Okay. Oh, no, that's wrong. If I do... Oh. If I do... Wait. I'm confused. Yeah, this one. Can I do half-man coding with that one? And so this becomes... Oh my god. Can this thing take it? Convert? Oh no, the website frozen. Oh my god, that's fine actually. It's just frozen this website, but we'll see when it come back. Oh, it does. Nice. Okay. Okay. Oh, does this thing ask? Does this thing ask the AI? What? Me? Okay. What's the longest URL here? Oh my god. Okay, fine. Okay. So we decided to do half-man coding. You can call the API with it. And what is the latency that we're looking at? So that's what I'm thinking. Any database would just be fine. You literally have, if we do Postgres, like this. I should just do Markdown instead. But this is SQL. It will be, we'll do input URL. Let's just say, let's just do 8,000. Be output URL char 1,000. No, it's gonna be complete the table for shortener. Right, so given this, we would output this. Right. So we'll have to come back in a little bit because we'll continue this tomorrow. Because tomorrow, so tomorrow we want, so this, all of this is right now 0129 26. Tomorrow we want to look at how do we guarantee like uniqueness. So the same color with the same URL, when it's already this, we just return. So we improve latency. So basically we have, is that called idempotency, right? And we want to know in the event of outage, how do we perform? Right, so that will be 0136, and we want to finish the deep dive. So talk about scaling caching, because like if multiple people call with the same input, right, we would how do we let's say equal with a big string, do we let one win and throttle others, or how do we do it, right? Because ideally, something we want to think about is TTL, right? Expire time, right? PostgreSQL spiral, right? Cleanup. So basically, expired is the timestamp. What is Postgres timestamp? Declare. We can do timestamp, and should we do a NoSQL 1, right? So far, let's summarize what we have. So we have so we have this high level design. We have a component that handle the traffic to the website, and somehow it would have to do backend, right? So we'll have to talk about if you call with the same request too many times, what would happen, right? And we have we have an API. The input string is this. What's the max size, right? So we think it could be 8,000 characters, right? And the output will be another string. Success, return 200. 429 if there's too many requests. And what is the error code for when same request happening? 429, right? Conflict, right? 409 conflict, right? In the case too many requests, scheduling too many requests at the same time. It might be conflict in the front end purely because we can just resolve the conflict in the backend. But how do we but do we sacrifice some sacrifice user other users for one succeed, like, or like multiple requests we give only one succeed, or because the algo is the same we always determine what the outcome look like. So we just store them we just queue and store them in the backend while we serving it. Right. Okay. That probably has some caching stuff. Okay. So tomorrow we'll look into this. Do we store the table or we just whatever they request? We just technically do we even need the table if we just gonna do Huffman coding anyway? Right? We mean that even you see what I'm saying, like even if we paste this thing, right? It takes some time to return here. Right? So what is that latency look like? Right? So what is Huffman coding complexity, right? Let's see what we want to know. N log n, right? So n is capped at 2000, right? So log n will be up characters, right? No, 8000. Yeah, something like that. But tomorrow we will continue with this, and we should have some way to have some graph, right? So basically the URL shortener version of mine is I give an API, have a string, so the input maximize basically 8000 according to the URL, right? And this is the exception that it's going to look like. And I'm gonna use Huffman coding, right? So we'll have a table and this table will be behind cache because, like I said here, in the case, even though we know the algorithm, right, it could be even faster if we pre-compute the result because we've seen that before, right? Something like that, right? So tomorrow we'll visit the deep dive. We will think about scaling, caching, and partitioning. But this is good enough, right? So like example.com will become 79788 FOD6 because we utilize half-band coding. Right. The other compression algorithm that they use, they suggest here, right? What did they suggest here? What? I'm so lost right now. What's my URL? Okay, yeah. They said the arithmetic coding asymmetric numeral system is faster. I haven't looked at this, but like I asked the Gemini here, if you do example.com, it turn it into this, right? It's like you save 60%. But tomorrow we probably implement Huffman coding in Python. We will see. We'll try and understand that. Okay. So this is what I have so far. Tomorrow we have to look at the step 4, which is what it is here. Because I'm just following what does the system design question should have. And what would you answer, right? So I'm at step 3 right now for design URL shortener. But tomorrow we'll wrap up step 4 and we'll compare what does this Gemini answer to the thing is. But my main thing is that we'll use Huffman coding. Right. Okay. It's 8,000 characters, nothing. And we want to do DynamoDB, MongoDB, or something else. If we want a NoSQL version of it, what should we do? Okay, so that's it for today. Because I'm gonna take a break for 5-10 minutes. Then I play some games. Then I sleep. Tomorrow morning we'll go back to this and we'll write a Substack answer for this, and we'll go back to LeetCode in the afternoon, maybe depend what time I wake up tomorrow. But like, if anyone watching this, you can just look back at my live stream to see the process of my thinking till then, if it's useful for you. But I think that's it for today. I'm gonna have to switch the game in 5 to 10 minutes. So that's it.